Now, I've got to say something to introduce Martin, and I was asking over dinner, what should I say? How can one introduce Martin? And the best advice I had was, briefly. But it's almost impossible to do that. Former President of the Royal Society, Master of Trinity, Order of Merit, Astronomer Royal, all kinds of things. He set up rival organizations to CSAR, namely CSAP and CSER. How confusing. Anyway, he's going to talk tonight about CSER. I should say that just in the conversation, we got on to the House of Lords. Martin is in the House of Lords, as you know. And someone was raised, and the question was asked, isn't he dead? And Martin's response was, no, he's in the House of Lords, a sort of death. And we then went on, I asked him, had he had his photograph, etc., and been filmed in the Ermine? He said, yeah, he did the procession in the Ermine, but he refused to be videoed. Tonight, there's no escape, but he's not wearing Ermine. Martin, over to you, and thank you very much.
Thank you very much, David. It's a pleasure to be here, although rather daunting. A few years ago, I met a well-known Indian tycoon. Knowing I had the title Astronomer Royal, he asked, do you do the Queen's horoscopes? And I responded with a straight face, if she wanted one, I'm the person she'd ask. But he then seemed eager for my predictions. I told him that stocks would fluctuate, there'd be trouble in the Middle East, and other deep insights like that, and he paid rapt attention. But I then came clean. I said I was just an astronomer, not an astrologer. And he then lost all interest in my predictions. And rightly so, because scientists are indeed rotten forecasters, almost as bad as economists. Nor do politicians and lawyers have a sure touch. In fact, one rather surprising futurologist, for historians here, was Lord Birkenhead, a crony of Churchill and Lord Chancellor in the 1920s. He wrote a book called The World in 2030. He'd read Wells and Bernal. He imagined babies incubated in flasks, flying cars, and such like fantasies. And this is his book, which has become a collector's item because of the modernist illustrations in it. But although he was futuristic on technology, he foresaw social stagnation. Let me give you just one quote. He said, in 2030, women will still, by their wit and charms, inspire the most able men towards heights that they could never themselves achieve. Enough said. Well, mindful of these precedents, my forecasts are going to be very tentative. Astronomers think in billions of years. But even in that perspective, this century is special. The Earth existed for 45 million centuries. Humans for a few thousand centuries, technology for a few tens of centuries. But this century is the first when one species, ours, is so empowered that it has the planet's future in its hands. We're deep in an era that's called the Anthropocene. We have huge powers for good, but we could irreversibly degrade the biosphere, or misdirected technology, bio or cyber, could cause a catastrophic setback to civilization. More than 10 years ago, I wrote a book on this theme, which I entitled Our Final Century, ? The publishers cut out the question mark. And the American publishers changed the title to Our Final Hour. Americans like instant gratification and the reverse. Well, I didn't think we'd wipe ourselves out, but I did think that we'd be lucky to avoid devastating setbacks. And we've had one lucky escape already. At any time in the Cold War, when armament levels escalated beyond all reason, the superpowers could have stumbled towards Armageddon through muddle and miscalculation. At the Cuba crisis or other times. Now, nuclear weapons are based on 20th century science, and I'll focus later in my talk on 21st century science, bio, cyber, and AI, which offer huge potential benefits, but also I think will expose us to novel vulnerabilities. But before that, let's focus on the long-term threats that stem not from conscious decisions, but from humanity's ever heavier collective footprint. Because even with a cloudy crystal ball, there are some things we can predict. For instance, it's almost inevitable that by mid-century, the world will be more crowded. 50 years ago, world population was about 3 billion. It now exceeds 7 billion. The growth's been mainly in Asia and Africa, as shown on this map, where regions are distorted in proportion to the amount of growth in those regions in the last 30 years. Now, the number of births per year worldwide actually peaked a few years ago, and it's going down. Nonetheless, world population is forecast to rise to about 9 billion by 2050. And that's partly because most people in the developing world are young. They're yet to have children, and they live longer. The age histogram in the developing world, on the left, will become more like it is in Europe on the right. The high age groups will fill up. The main growth is going to be in East Asia. And it's there, of course, that the world's human and financial resources are going to become concentrated. I think we're going to see the end of 4 centuries of North Atlantic hegemony. And there's more urbanization. Even by 2030, Lagos, Sao Paulo, and Delhi will have populations of more than 30 million. And to prevent these megacities becoming turbulent dystopias will surely be a major challenge to governance. Population growth seems under-discussed. That's maybe because doom-laden forecasts in the 70s by the Club of Rome, Paul Ehrlich and others have proved off the mark. And because up till now, food production has more than kept pace. Famines now stem from wars or maldistribution, not overall food shortage. And some deem this a taboo subject, tainted by association with eugenics in the 20s and 30s, with Indian policies under Indira Gandhi, and more recently with China's hardline one-child policy. But we need to ask, can the Earth, as it were, carry 9 billion people? I don't think there's any need for gloom or panic on this front. Certainly our Cambridge experts, people like Sir David Bolcombe, have averred that improved agriculture, low-till, water conserving, and perhaps involving GM crops, could feed that number by mid-century. The buzz phrase is sustainable intensification. But lifestyle changes will be needed. The world couldn't sustain even its present population if everyone lived like Americans do today, using as much energy and eating as much beef. Population trends beyond 2050, they're harder to predict. They'll depend on what people, as yet unborn, decide about the number and spacing of their children. Enhanced education and empowerment of women, a benign priority in itself, may reduce fertility rates. But this demographic transition hasn't yet reached parts of India nor sub-Saharan Africa. And indeed, if families in Africa remain large, then according to the UN, that continent's population could double again between 2050 and 2100 to 4 billion, thereby raising global population to 11 billion. Nigeria alone would then have as big a population as Europe and North America combined, and almost half the world's children would be in Africa. Well, optimists remind us that every extra mouth brings also 2 hands and a brain. Nonetheless, the higher the population becomes, the greater will be all pressure on resources, especially if the developing world narrows its gap with the developed world in per capita consumption, as we surely hope. And the harder it will be for Africa to escape the poverty trap. So we must surely hope that the global figure will decline rather than go on rising after 2050. But As I say, this is an uncertain projection. Moreover, if humanity's collective impact on nature pushes too hard against what the Swedish scientist Johan Rockström calls planetary boundaries, the resultant ecological shock could irreversibly impoverish our biosphere. Extinction rates are rising. We are destroying the book of life before we've read it. Biodiversity is a crucial component of human well-being. We're clearly harmed if fish stocks dwindle to extinction. There are plants in the rainforest whose gene pool might be useful to us. But for many environmentalists, preserving the richness of our biosphere has value in its own right, over and above what it means to us humans. To quote the great ecologist E.O. Wilson, mass extinction is the sin that future generations will least forgive us for. So the world's getting more crowded. And as a second firm prediction, it'll gradually get warmer. In contrast to population issues, climate change is certainly not under-discussed, though it may be underacted upon. This is a famous Keeling curve showing the concentration of CO2 in the atmosphere. It's rising, mainly due to the burning of fossil fuels. And the seasonal oscillation is because there's more vegetation in the northern than in the southern hemisphere. And that gives an annual fluctuation. The fifth IPCC report presented temperature projections for the future for different assumptions about future rates of fossil fuel use. Those are these four lines here. For each of these assumptions, there's a spread indicated by the bar on the right, and that's because of uncertainty in the modeling. It's unclear the extent to which the well-understood greenhouse effect due to CO2 is amplified by associated changes in water vapor, cloud cover, etc. This is a so-called sensitivity factor, which is uncertain. But despite these uncertainties, the science tells us that under business-as-usual scenarios, we can't rule out, by 2100, really catastrophic warming and tipping points triggering long-term trends like the melting of Greenland's ice cap. Sadly, some do deny this. But the point I want to make is that even among those who accept that this threat is real, there's a range of views. And these wide-ranging views stem from differences in economics and ethics, in particular in how much obligation we should feel towards future generations. Some of you may know about Born Lomborg and his Copenhagen consensus of economists. He applies commercial-style discounting and in effect therefore writes off what happens beyond 2050. So unsurprisingly, he downplays the priority of addressing climate change in comparison with shorter-term efforts to help the world's poor. But if you care about those who will be still alive in the 22nd century and beyond, then, as other economists like Stern in this country and Weizmann at Harvard argue, you would deem it worth paying an insurance premium now to protect those generations against the worst-case scenarios. So above all, it depends on an ethical issue. In optimizing people's life chances, should we discriminate on grounds of date of birth? So in other words, even those who agree that there's a significant risk of climate catastrophe a century hence will differ in how urgently they advocate action today. Their assessment will depend on expectations of future growth and optimism about technological fixes, but above all, it depends on this ethical issue: how much do we care about future generations? As a parenthesis, I'd notice that there's one policy context where an essentially zero discount rate is applied. This is to radioactive waste disposal, where the depositories are required to prevent leakage for 10,000 years. It's somewhat ironic when we can't even plan the rest of energy policy 30 years ahead. Consider this analogy. Suppose astronomers had tracked an asteroid and calculated that it would hit the Earth in, say, 2080, 63 years from now. not with certainty, but with, say, 10% probability. Would we relax, saying it's a problem that could be set on one side for 50 years? People will then be richer, and it may turn out it's going to miss the Earth anyway. I don't think we would. There'd surely be a consensus that we should start straight away and do our damnedest to find ways to deflect it or mitigate its effect. Many still hope that our civilization can segue smoothly towards a low-carbon future and be on the bottom of those four curves. The pledges made at the Paris conference were a positive step. But even if they're honoured, this may not lead to cuts fast enough to prevent CO2 concentrations rising to dangerous levels. Politicians seldom take a long-term view, and they won't gain much resonance by advocating unwelcome lifestyle changes now, when the benefits accrue mainly in distant parts of the world and decades in the future. That's why it's going to be hard to implement Paris. But there's one measure to mitigate climate change which genuinely seems a win-win scenario. It's that nations should accelerate R&D into all forms of low-carbon energy generation, renewables, fourth-generation nuclear, fusion, and the rest, and into other technologies where parallel progress is crucial, especially storage, batteries, compressed air, pumped storage, flywheels, etc., and smart grids. That's why one encouraging outcome of Paris was an initiative called Mission Innovation, endorsed by more than 20 nations, which was a campaign to double publicly funded R&D into clean energy by 2020. And it was a parallel pledge by Bill Gates and other private philanthropists to put in a few $1 billion of their own. Well, that target is a modest one, because presently only 2% of publicly funded R&D is devoted to these challenges. So why shouldn't this percentage be comparable to spending on medical or defense research? Because the faster these clean technologies advance, the sooner will the prices fall, so that they become affordable to India, for instance, where more generating capacity will be needed and where the health of the poorest is now jeopardized by smoky stoves burning wood or dung, and where there would otherwise be pressure to build coal-fired power stations. All renewables have their niches, wind, tide, waves, and hydro here in the UK, for instance. And for Europe, maybe a large-scale transcontinental grid to smooth east-west over time zones and to carry solar energy from the sunny south to places like Britain. And we need efficient storage as well. It would be hard to think of a more inspiring challenge for young engineers than devising clean energy systems for the world. And just a digression, I should say that most of what I'm talking about is a need for more and better directed engineering. I feel a bit embarrassed because I myself am a scientist of a rather armchair theory type. And I'd like to put in some preemptive modesty and emphasize that even in sciences like what I do, 90% of the advance is owed to the engineers who build wonderful instruments. Armchair theorists like me would do not very much. And I like to remind engineers of a cartoon that they always enjoy, which shows two beavers looking up at a big hydroelectric dam. One beaver says to the other, "I didn't actually build it, but it's based on my idea." That indicates the balance between the idea and the massive challenge of implementation. Well, clean energy is one such challenge. But supposing that 20 years from now, CO2 annual emissions are still going up, and suppose it's by then clear that the temperature is rising at a rate consistent with a high climate sensitivity, then it may seem then that we are heading irreversibly into dangerous territory. And there may then be pressure for some kind of panic measures, like geoengineering. This would be a plan B, being fatalistic about continuing dependence on fossil fuels, but combating its effects by either a massive investment in carbon capture and storage, or else by geoengineering. It's feasible, for instance, to inject enough aerosols into the stratosphere to cool the world's climate. Indeed, what's scary is that this might be within the resources of a single nation, even a single corporation. And there would be unintended side effects. Moreover, the warming would return with a vengeance if the countermeasures were discontinued, and other consequences of rising CO2, especially the deleterious effect of ocean acidification changes, would be unchecked. Geoengineering would be a political nightmare. Not all nations would want to adjust the thermostat the same way, and very elaborate climatic modeling will be needed in order to calculate the regional impacts of any artificial intervention. The only beneficiaries will be the lawyers. They'd have a real bonanza if nations could litigate over bad weather. Nonetheless, I think it's prudent to explore geoengineering techniques, as is being done here in other places, enough to clarify which options make sense and perhaps damp down undue optimism about some kind of quick fix to deal with our climate. I think we should be evangelists for new technologies. Without them, the world can't provide food and sustainable energy for an expanding and more demanding population. But we need wisely directed technology. Advanced renewables are wise goals. Geoengineering techniques probably aren't wise goals. But what about the other technologies that pervade our lives? Can we cope with their headlong advance? Let me expand on these concerns now. We're getting more vulnerable. Our increasingly interconnected world depends on elaborate networks, electricity power grids, air traffic control, international finance, globally dispersed manufacturing, and so forth. And unless these networks are highly resilient, their benefits could be outweighed by catastrophic, albeit rare, breakdowns. Our cities will be paralyzed without electricity, air travel could spread a pandemic worldwide within days, and social media can spread panic and rumor and economic contagion literally at the speed of light. Well, there are antidotes, advances in microbiology, for instance. Diagnostics, vaccines, and antibiotics offer prospects of containing pandemics. But even research in microbiology has controversial aspects. For instance, in 2012, groups in Wisconsin and in Holland showed it was surprisingly easy to make the influenza virus both more virulent and more transmissible. They argued that to understand the virus better, we had to stay one step ahead of natural mutations. But to some, this was a scary portent of things to come. And it was to the US federal government, which in 2014 decided to cease funding these so-called gain-of-function experiments. And the new CRISPR-Cas9 technique for gene editing is again hugely promising, but there are ethical concerns raised already by Chinese experiments on human embryos. And gene drive programs can be deployed to wipe out entire species. Mosquitoes that carry the Zika virus, for instance. But some lovers of brown squirrels would like to eliminate the grey ones. And that could, in principle, be done too. But disturbing natural ecologies clearly risks unintended consequences. Back in the early days of recombinant DNA research in the 1970s, leading biologists met at a famous meeting in Asilomar, California, and they agreed guidelines on what experiments should and shouldn't be done. This was an encouraging precedent, and it's motivated several meetings recently to discuss these new powerful developments in the same spirit. But today, 40 years after the original Asilomar conference, the research community is far more broadly international and more influenced by commercial pressure. And I'd worry that whatever regulations are imposed on prudential or ethical grounds can't be enforced worldwide. any more than the drug laws can or the tax laws. I worry that whatever can be done will be done by someone somewhere. And that's a nightmare. Whereas an atomic bomb can't be built without large-scale special-purpose facilities, biotech involves small-scale, dual-use equipment. Indeed, biohacking is burgeoning even as a hobby and competitive game. And we know all too well that technical expertise doesn't guarantee balanced rationality. The global village will have its village idiots, and they'll have global range. The rising empowerment of tech-savvy groups, or even individuals, empowered by bio as well as cyber technology, will pose an intractable challenge to governments and aggravate the tension between freedom, privacy, and security. Well, these concerns about bioair and bioterror are, I think, fairly near term, within the next 10 to 15 years. But what about 2050 and beyond? The smartphone, the web, and their ancillaries are crucial to our network lives today, but they'd have seemed magic even 20 years ago. So looking several decades ahead, we must keep our minds open, or at least ajar, to innovations that might now seem pure science fiction. On the bio front, the great physicist Freeman Dyson, for instance, conjectures a time when children will be able to design and create new organisms, just as his generation played with chemistry sets. Well, if it really became possible to, as it were, play God on a kitchen table, then our ecology and even our species may not survive long unscathed. So let's hope that is science fiction. And what about another transformative technology? Robotics and artificial intelligence, AI. There's been exciting advances in what's called generalized machine learning. And I know Demis Hassabis addressed this society recently, and his company, DeepMind, last year achieved a remarkable feat. Its computer beat the world champion in the game of Go. You heard about this from him, and I won't go into any details. I'd mention also that Carnegie Mellon University has developed a machine that can bluff and calculate as well as the best human poker player. Of course, it's 20 years since IBM's Deep Blue beat Kasparov. So it may not seem such a big deal that the Go-playing computer is so strong now, but there's a big difference. Deep Blue was programmed in detail by expert players. In contrast, the machines that play Go and poker gained expertise by absorbing huge numbers of games and playing against themselves. Their designers don't themselves know how the machines make seemingly insightful decisions. The speed of computers, this familiar trend, allows them to succeed by brute force methods. They learn to identify dogs, cats, and human faces by crunching through millions of images, not the way a baby learns. They learn to translate by reading millions of pages of, for example, multilingual EU documents. They never get bored. But advances are patchy. Robots are still clumsier than a child in moving pieces on a real chessboard. They can't tie your shoelaces or cut old people's toenails. But sensor technology, speech recognition, information searches, and so forth are advancing apace. They won't just take over manual work. Indeed, plumbing and gardening will be among the hardest jobs to automate. But routine legal work, conveyancing and such like, medical diagnostics, even surgery and computer coding will be taken over. And the big social and economic question is this: will the second machine age be like earlier disruptive technologies, like the car replacing the horse, for instance, which create as many jobs as they destroyed? Or will it really be different this time? The money earned by robots could generate huge wealth for an elite. But to preserve a healthy society will, I think, require massive redistribution to ensure that everyone has at least a living wage. And I think not just a living wage for doing nothing, but dignified employment, which could be supplied by creating the money for upgraded public service jobs where the human element is crucial and is now undervalued and demand is huge. Especially carers for young and old, but also custodians, gardeners in public parks, and so on. So massive social redistribution is going to be needed. But let's look further ahead. If robots could observe and interpret their environment and engage with it, as we do, they would truly be perceived as intelligent beings, to which or to whom we can relate. Such machines pervade popular culture in movies like Her, Transcendence, and Ex Machina. So, would we then have obligations towards them? We worry if our fellow humans, and even some animals, can't fulfill their natural potential. So should we feel guilty if our robots are underemployed or bored? And what if a machine develops a mind of its own? Would it stay docile, or would it go rogue? If it could infiltrate the internet and the Internet of Things, it could manipulate the rest of the world. And it may have goals utterly orthogonal to human wishes, or even treat humans as an encumbrance. Now, some AI pundits take this seriously and think the field already needs guidelines, just as biotech does. But there are others who regard these concerns as premature and worry less about artificial intelligence than about real stupidity, and think that'll be the situation for a few more decades. But be it as it may, it's likely that society will be transformed by autonomous robots, even though the jury's out, as I said, on whether they'll be idiot savant or display superhuman capability. There's disagreement, incidentally, about the route towards human-level intelligence. Some think we should emulate nature and try to reverse engineer the human brain. Others say that's as misguided as designing flying machines by copying how birds flap their wings. And of course, philosophers debate whether consciousness is special to the wet organic brains of humans, apes, and dogs, so that robots, even if their intellect seems superhuman, will still lack self-awareness or inner life, or if, on the other hand, consciousness is an emergent property beyond any level of complexity. The futurologist Ray Kurzweil, now working at Google, he argues that once machines have surpassed human capabilities, they can themselves design and assemble a new generation of even more powerful ones. We'll get an intelligence explosion, what some people call a singularity. He thinks that humans could transcend biology by merging with computers. In old-style spiritualist parlance, they would go over to the other side. But Kurzweil is worried that this may not happen in his lifetime. He's in his 60s. So he wants his body frozen until this nirvana is reached. I was once interviewed by a group of these so-called cryonic enthusiasts based in California. Where else? It was called the Society for the Abolition of Involuntary Death. And they will freeze your body. There's a company in Arizona that does this, so that when immortality is on offer, you can be resurrected or your brain downloaded. Well, I told them I'd rather end my days in an English churchyard than in a Californian refrigerator. And they derided me as a deathist, a really old-fashioned man. Well, I was surprised to find that 3 academics in this country had gone in for cryonics. 2 had paid the full whack. The 3rd had taken the cut-price option of wanting just his head frozen. And I was glad that they were from Oxford and not from here. But of course, research on aging is being seriously prioritized. Will the benefits be incremental, or is aging a disease that can be cured? Dramatic life extension would plainly be a real wild card in all the population projections I gave you, with huge social ramifications. But it may happen along with human enhancement in other forms. But it's in deep space, my own special interest, where robots will surely be transformative. During this century, the whole solar system will be explored by flotillas of militarized probes, far more advanced than the ones we've had now, more advanced than the European Rosetta, which landed a little robot on a comet, or NASA's New Horizon probe that transmitted back amazing pictures of Pluto 10,000 times further away than our moon. These two instruments took 10 years on their journey, and of course 5 years in the planning stage, so they were using 1990s technology. Think how much better we could do now when you think how smartphones have changed. And the amazing Cassini probe of Saturn is even more of an antique. It was launched 20 years ago. Think how much better we could do today. And we could do better too than the Curiosity probe that's been trundling across the Martian surface for the last 4 years. Later this century, one can imagine that giant robotic fabricators up in orbit may assemble vast lightweight structures in space. Gossamer-thin radio telescopes, maybe solar energy collectors, etc., maybe using raw materials mined from the moon or from asteroids. But what about human spaceflight? As robots and AI advance, the practical case for sending humans and the need for them is clearly eroding. Nonetheless, I hope people will follow the robots, though it will be as risk-seeking adventurers rather than for practical goals. The most promising developments are spearheaded by private companies. Elon Musk's SpaceX has launched unmanned payloads and docked with the space station, and has successfully recovered and reused the launch rocket's first stage, presaging real cost savings. He hopes soon to offer orbital flights to paying customers. And wealthy adventurers are already signing up for a week-long trip round the far side of the moon, voyaging further from Earth than anyone has been before. I'm told they've sold a ticket for the second flight, but not the first flight. That may tell you something. But we should surely acclaim these private enterprise efforts in space, because they can tolerate higher risks than a Western government could impose on publicly funded civilian astronauts, and thereby cut costs compared to NASA or ESA. But these should be promoted as adventures or extreme sports. The phrase space tourism should be avoided, because that lulls people into unrealistic confidence. But I think that by 2100, courageous pioneers in the mold of, say, Felix Baumgartner, who broke the sound barrier by falling from a very high altitude balloon, or our own Sir Ranulph Fiennes, who has dragged sledges across the Antarctic in winter and other crazy things. People like that may have established bases independent from the Earth, on Mars or maybe on asteroids. And Elon Musk himself has said that he wants to die on Mars, but not on impact. And he's 45 years old, so this may be realistic in 40 years' time. But don't ever expect mass emigration from Earth, because nowhere in our solar system offers an environment even as clement as the Antarctic or the top of Everest. It's a dangerous delusion to think that space offers an escape from Earth's problems. There's no planet B, as it were. Indeed, space is an inherently very hostile environment for humans. And for this reason, even though we may wish to regulate genetic and cyborg technology on Earth, we should surely wish these adventurous space pioneers out there on Mars good luck in using all the techniques we'll have later in this century to adapt to alien conditions. They'll be free from terrestrial regulations, and they'll have maximal incentive to do so. Indeed, these spacefarers may spearhead the post-human era, evolving within a few centuries into a new species. And let me expand on this. As an astronomer, I'm sometimes asked, does contemplation of huge expanses of space and time affect your everyday life? Well, having spent much of my life among astronomers, I have to tell you they're not especially serene, and they fret as much as anyone about what happens next week or tomorrow. But they do bring one special perspective, an awareness of the far future. Let me explain. The stupendous time spans of the evolutionary past are now parts of common culture. Outside fundamentalist circles, Kentucky and the Muslim world, for instance. But most people who accept this time chart nonetheless tend to regard humans as a culmination of the evolutionary tree. And that doesn't seem credible to any astronomer, because we know that our sun formed 4.5 billion years ago, but it's got 6 billion more years before the fuel runs out. And the expanding universe will continue perhaps forever. To quote Woody Allen, eternity is very long, especially towards the end. So we may not even be at the halfway stage of evolution, not just on Earth, but far beyond. So it may take just decades to develop human-level AI, or it may take centuries. But be it as it may, that is but an instant compared to the cosmic future lying ahead. Moreover, the Earth's environment may suit us organics, but interplanetary and interstellar space may be the preferred arena where these robots will have the grandest scope for construction, and where non-biological brains may develop powers that we humans can't even imagine. Well, this raises the question that astronomers are most often asked. Is there life out there already, or is the galaxy waiting for our post-human progeny to get there? Now, we know there's nowhere in our solar system that harbors advanced life. We won't have Wells's War of the Worlds. However, there may be some freeze-dried bacteria on Mars, the red planet, and there may be creatures swimming under the ice on Saturn's moon Enceladus. But let's widen our horizon to the realm of the stars. And we've learnt, mainly in the last decade, that most stars in the sky are orbited by retinues of planets, like the Sun is. But the evidence for this is so far mainly indirect. We don't see the planets. What we do see is a small dimming if a planet moves across and transits a star, or a small wobble in the star's motion due to the pull of a planet. We can't directly see the planets yet, but we can infer the masses of the planets and their size. We've learned quite a lot about them. And this is a very exciting subject, but the important message is this, that almost every star has a planet around it, and 1 in every 6 stars, roughly, has an Earth-sized planet around it. And there's, of course, special interest in possible twins of our Earth, planets the same size as ours, and on orbits such that water doesn't boil away, as it would if they're too close to the star, nor do they stay frozen all the time. And almost certainly millions of such planets in the so-called habitable zone in our Milky Way galaxy. In fact, there's one orbiting the very nearest star, Proxima Centauri, just over 4 light years away. And just last year, another amazing system was discovered. I won't say what's called TRAPPIST-1, that's a complicated acronym, but this was a system of 7 planets orbiting around a star which is about 1% as bright as the Sun. It's a miniature solar system. The star is very small and very red, and the 7 planets are orbiting around, and their years are just a few days in our time. So it's a miniature solar system. And at least the outer 3 of these planets are in the habitable zone in that water could exist. So will there be life on them? Maybe even intelligent life. They'd be spectacular places to live, because viewed from the surface of one of them, the other planets would loom larger in their sky than our moon does in ours. And you'd see these planets zooming across the sky. And the real goal, and they're very unearthly. They're probably tidally locked, so that they present the same face to their star all the time. So one half of them one hemisphere is in perpetual light, one in perpetual darkness. So there'd be a kind of apartheid where the astronomers will be in one hemisphere, everyone else in the other. Well, as I said, they're very unearthly, but we'd like to know more about them. But the real goal is to image exoplanets like these directly, not just to infer them from their indirect effects on their parent star. And that's hard. To realize just how hard, suppose an alien astronomer with a powerful telescope was viewing the Earth from, say, 30 light years away, the distance of a nearby star. Our planet would then seem, in Carl Sagan's nice phrase, a pale blue dot, very close to its star, our sun, which would outshine it by many billions. A firefly next to a searchlight, as it were. But if the aliens had a big telescope, they could learn quite a bit about this pale blue dot. The shade of blue would be a bit different, depending on whether the landmass of Eurasia or the Pacific Ocean was facing them. So they could infer the length of the day, that there were continents and oceans, something about the climate, and maybe something about the seasons, and also by analyzing the faint light, they could probably infer that it was out of an atmosphere out of equilibrium, indicating a biosphere. Well, we can't yet do that, but within 10 years or so, we will have telescopes that will be able to draw just such inferences about Earth-like planets orbiting other nearby stars. In the lead is this telescope, where construction has just started. It's going to be built by a consortium of European countries, the European Southern Observatory, which we will remain in independent of Brexit. Europeans are rather unimaginative in their nomenclature. It's called the Extremely Large Telescope. And it is indeed extremely large. Its mirror, which is a mosaic of nearly 1,000 pieces, is 39 meters across. That's, I would guess, about twice the width of this room. It's a huge mirror. And this instrument will be able to draw inferences about exoplanets the size of our Earth. Well, habitable planets doesn't mean the same as inhabited planets. But for most of us, that's the number one question. We still don't know the likelihood because we know too little about how life began on Earth to lay confident odds. We don't know what triggered the transition from complex molecules to entities that can metabolize and reproduce. It might have evolved a fluke so rare that it only happened once in the entire galaxy, and that's where we happen to be. On the other hand, this transition might have been almost inevitable given the right environment. We just don't know. Nor do we know whether the DNA, RNA chemistry of terrestrial life is the only possibility, or just one chemical basis among many options that could be realized elsewhere. Moreover, even if simple life is widespread, we can't assess the odds that it evolves into a complex biosphere. And even if it did, it might be unrecognizably different. For instance, life around a star older than the Sun could have had a head start of 1 billion years or more. Thus, it may already have spawned the futuristic scenario, transitioning from organic to electronic, which I envisaged as the future of our Earth. So, even if SETI searches, so-called, reveal some artificial emission, we'd be most unlikely to catch alien intelligence in the brief sliver of time when it was still in organic form, because that may be only a few centuries compared to the billion or more years when you get the electronic post-humans. And so if SETI searches reveal something, I think it's unlikely to be some sort of decodable message, more likely to be a byproduct or even a malfunction of some supercomplex interstellar technology which could trace its lineage back to alien organic beings, which might still exist on their home planet or might long ago have died out. Moreover, the habit of referring to ET as an alien civilization may be too restrictive because a civilization connotes a society of individuals. In contrast, ET might be a single integrated intelligence. I won't hold my breath, but SETI programs are a worthwhile gamble because success in the search would carry the momentous message that concepts of logic and physics aren't limited to the hardware in human skulls. And I've agreed to chair an intensive search for radio and optical signals, a 10-year program bankrolled by Yuri Milner, a Russian billionaire investor. And I think it's far better that he should spend his money this way than on a big yacht or a football team. I've got no time to speculate further beyond this flaky fringe, which is perhaps a good thing. So let me just conclude in the final few minutes by focusing back a bit closer to the here and now. My theme has been that even in the concertina timeline that astronomers envisage, extending billions of years into the future as well as into the past, this century may be a defining era. The century when humans jumpstart the transition to electronic and potentially immortal entities, which may spread their influence far beyond the Earth, or, to take a darker view, the century when our follies could foreclose that immense future potential. So, there are risks. And we fret unduly, I think, about small, well-known risks. Air crashes, carcinogens in food, low radiation doses, etc. But I'd argue we're in denial about some newly emergent threats, which may seem improbable, but whose consequences could be globally devastating. Some of these are environmental, others are the potential downsides of novel technologies. And I've alluded to some of these earlier on. So how can those of us concerned about these issues influence policy makers in a way to make the world safer? The trouble is that even the best politicians focus mainly on the urgent and parochial and getting re-elected. And this is an endemic frustration for those who've been official science advisors in governments. To attract politicians' attention, you must get headlined in the press and fill their inboxes. So scientists can have more leverage indirectly by campaigning so that the public and the media amplify their voice. And I think scientists should all be prepared to divert some of their efforts towards public policy and engage with government, business and NGOs to write blogs, etc. They have an obligation to engage. In fact, the great mathematician Michael Atiyah offered a nice analogy. He said, if you've got teenage kids, you've got limited influence over them. But you're poor parents if, despite that, you don't care about them. Likewise, scientists shouldn't be indifferent to the fruits of their ideas, which are their creations. So we need more focus on issues which are long-term in political perspective, even if a mere instant in the history of our planet. And that's something that universities can help with, partly because they're full of young people who live to the end of a century, and moreover, universities like ours should use their convening power to gather experts together to address these problems. And that's why some of us have set up the Centre for the Study of Existential Risks, which David Wallace alluded to, with a focus on the more extreme, low probability, high consequence threats that might confront us. These threats surely deserve expert analysis to assess which can be dismissed firmly as science fiction and which should be on the risk register, and to consider how to enhance resilience against the more credible ones, and to warn against technological developments that could run out of control. And indeed, even if we reduce these risks by only a tiny percentage, the stakes are so high that we'll have earned our keep. A wise mantra is that the unfamiliar is not the same as the improbable. But though we live under the shadow of these threats, and may be political pessimists, we must remain techno-optimists. Advances in AI, biotech, nanotech, and space can boost the developing as well as the developed world. Indeed, if we don't responsibly progress these new technologies, we won't achieve a bright future. Undiluted application of the precautionary principle has a manifest downside. We've got to have a balanced approach. And we're all on this crowded world together. Spaceship Earth is hurtling through the void. Its passengers are anxious and fractious. Their life support system is vulnerable to disruption and breakdowns. But it's too little planning, too little horizon scanning, too little awareness of long-term risks. And of course, the challenges are global, coping with potential resource shortages and transitioning to low-carbon energy clearly can't be achieved by each nation separately. Well, that's my main message, and I want to conclude with some words from two scientific sages from the past. First, H.G. Wells, even further back than Lord Birkenhead and far wiser. Back in 1902, Wells was already alert to the risk of global disaster. In a famous lecture, he said this: "It is impossible to show why certain things should not utterly destroy and end the human story, and make all our efforts vain. Something from space, or pestilence, or some great disease of the atmosphere, some trailing cometary poison, some great emanation of vapor from the interior of the earth, or new animals to prey on us, or some drug or wrecking madness in the mind of man." But nonetheless, he retained a vision. I quote again: "Humanity has come some way, and the distance we have traveled gives us some earnest of the way we have to go. All the past is but the beginning of a beginning. All that the human mind has accomplished is but the dream before the awakening." Well, his rather purple prose still resonates more than 100 years later. Were Wells writing today, he'd have been elated by our expanding vision of life in the cosmos, but he'd have been, I think, even more anxious about the perils we may face. He reflects the mix of optimism and anxiety, and of speculation and science, which I've tried to offer in this lecture. But we mustn't leap from denial to despair, so I give the last word to another sage, the great biologist Peter Medawar. I quote: "The bells that toll for mankind are like the bells of alpine cattle. They're attached to our own necks, and it must be our fault if they do not make a tuneful and melodious sound." Thank you very much.
Martin, we have time, despite the length of the applause, we have time for a few questions, and I hope
Sure.
you'll be happy to answer them. And that was an extraordinary talk. So we have two people with microphones. Please wait until you get a microphone and be clear when you're speaking, and brief. Lots of hands.
Thank you very much for a fascinating talk, Lord Rees. Our technological progress in the next decade or two rather depends on silicon, which we have in abundance, and exotic dopants, which we don't. They tend to be controlled by countries that we don't necessarily have great relations with in the West. I'd be interested in your views on the social, political, economic, and technological progress impacts of that.
Yes. Well, I'm not an expert on those. Indeed, the issue of the rare earths and the Chinese dominating the market is, of course, a serious one. All I can say is that issues like that are going to give us a bumpy ride in the economics of these new technologies. And, of course, to be on a positive note, to perhaps trigger the development of alternatives.
Hi. It was fascinating talk, and I would love to hear a little bit more on one aspect that you've given this grand vision to us, that perhaps humans are not the last stage of evolution. There could be this transition to electronic life and brains, and perhaps that's not even something that is a long time of evolution, if anything, in general. I'm curious if you could expand more, at least in your own vision, what some people might think, rather than just artificial intelligence and robots taking over, that all matter could become smart matter, in that it's an inevitable kind of part of evolution, that once you have these kind of atoms and molecules and everything built up, now we have materials that are starting to be responsive, and eventually all matter by itself is maybe supposed to be smart.
Yes. Well, that's, of course, a very long-range future scenario, but that's not crazy, because the one point I would make is that if indeed we get through this century, and at the end of the century, humans may be becoming cyborgs, or maybe by being overtaken by machines, then that future development, future evolution, will not be Darwinian, on the slow timescale of Darwinian natural selection, where it takes 1 million years or so for a species to emerge, evolve, and become extinct. The future evolution will be on a technological timescale. And that is clearly going to be much shorter than Darwinian selection, and that therefore means that the span of billions of years ahead allows even more scope than it would otherwise for new developments. So I think we've got to be completely open-minded about what might happen. Of course, before someone else asks this, then there is the famous argument about, due to Fermi, that if this is possible, are we really the first in the galaxy, or otherwise, why haven't we seen evidence of the ones with a head start over us? And again, we don't know. That's a constraint on this. But I think my main point is that once we have self-reproducing machines, which can design even better ones, which is the division of Kurzweil and von Neumann and lots of other people, then the future evolution is on a shorter timescale than Darwinian selection.
Thank you for your talk. I was really startled by your mention of exoplanets, and that the most stars have exoplanets, which is something I'd never heard of before. It's an amazing paradigm shift, like the Hubble Deep Field picture. When did that picture emerge? Is it quite recent?
Yes, I mean the first exoplanet of this kind was found. The co-discoverer was Professor Didier Queloz, who is now here in Cambridge. He was in Geneva at the time, and in the last decade, literally thousands have been discovered by looking at nearby stars very carefully. But in almost all cases, we have just the indirect evidence of the slight dimming of a star whenever a planet transits in front of it, or the small motion. But we now are pretty sure that planets are ubiquitous, and there's a huge variety. Our solar system may not be typical. Many systems have Jupiter-mass planets very close in, with orbits such that years only a few days. It's very, very complicated, very diverse. So certainly the night sky is hugely more interesting than it was 20 years ago, because every star in the sky, we know almost certainly, has a retinue of planets just like the sun does. And of course the question of what life is out there is now a more acute and more serious question.
Thank you. You've concentrated your talk on 2050 and what's going to be happening then. In particular, the population problem.
Yes, yes.
It does seem to me that we should be looking at the population problem we have now with 7 billion. I've seen it said, and I don't know how true this is, and I don't know who said it, that if everybody on the planet now was to have a European standard of living, we should need something like 3 planets to provide the raw materials to sustain that. If we had a North American standard of living, it goes up to about 5 planets. And it seems to me we have to worry about that. And what we ought to be concentrating on is not limiting the rise in population, but in fact in actually cutting it down substantially.
Well, as I said, we can't have the present population living like present-day Americans. I did say that, and maybe not even like present-day Europeans. We've got to perhaps become more vegetarian and cultivate more intensively. But again, I'm not that pessimistic. If you just think of the challenge of doubling food production, that may not be impossible with intensive cultivation, and engineering to minimize waste, etc. So I don't think we should be too pessimistic. But on the other hand, I'm sure you're right, and I would agree that beyond 2050, when population projections depend entirely on the decisions made by people as yet unborn as to how many children they will have, it would be far better if the population did start going down, because the ecological pressures are otherwise going to be greater. So I don't think we should be doomsters, because the population growth is not at the rate it was 50 years ago. It's not. It's going to level off, but we certainly would like to see it decline for just the reasons you mentioned.
I should explain that I'm deliberately denying CSAR council members, as they well know it's so unfair, but you have a chance later. Lady, please.
Hi, I'm worried about the biotech risk, because it seems to me that that people are creating organisms in the lab right now that could very easily be kind of released into the public and transmitted. Is that on the political radar? Are people are people dealing with that threat, or is it just completely ignored?
Well, again, I'm sure there are people in this audience who are more expert than me, but certainly it's already been possible to actually synthesize simple viruses, and that's going to become easier, and to modify them is going to become easier. So my concern really is, as I indicated, two things. That first, this technology is going to become widely understood, and secondly, the equipment it needs is dual use and very common. So it's not like building a nuclear bomb, where you need large, conspicuous special facilities. It's going to be very, very hard to prevent just a few rogues from misusing this technology, either by design or just by error. So I do think it is scary, and certainly people are indeed very worried about this.
Given the political time frame that you alluded to, so short-term politicians, do you think, is your instinct that we will resolve our problems through central planning or through the free market?
Well, I would just quote two things from our common colleague Amartya Sen. He was famous for saying that India, with its free press and democracy, had a big advantage over China because it couldn't hide its famines, and there were no famines, as there have been in China. But he has himself said that in those two countries, where the issues now are consistent development of infrastructure, he thinks the Chinese have an advantage from their system, so that they can more easily do long-term planning. But I don't see why we shouldn't be able to do it here. But certainly we do have to have a system of planning ahead. And as I say, I think we can do this by changing public opinion. Perhaps I could mention one thing, which is that one very effective force in the lead-up to the Paris Accord on climate change was the Papal Encyclical. And although I'm not a religious believer, I'm on the council of the Papal Academy of Sciences. And our Cambridge colleague, Sir Partha Gupta, who's a lapsed Hindu, and he, along with some others, organized a conference in the summer of 2014 on environment and sustainability and climate, which attracted some of the world's best scientists in those fields, plus also economists like Stiglitz and Jeffrey Sachs. And this was input into the Papal Encyclical, which came out in the summer of 2015, a few months before the Paris conference, and the Pope got a standing ovation at the UN when he presented it. And I think this was an important influence, because whatever you think of the Catholic Church, no one can deny its global range, its long-term vision, and its concern about the world's poor. And I think the religions are therefore able, in my view, to have a very important effect in determining people's long-term perspective, and to make them prepared when they vote to be more positive about things that may affect the lives of their grandchildren.
Two more questions already.
I think technological progress often has political and social implications, but I'm wondering if you think in the present day that's more true, that the technological progress that we're making is more likely to have social and political consequences. I'm wondering, one, if you think that's true, and two, what you think the duty of the public is, if that is true, in response to that. One, do schools and education have a responsibility to make that make people more aware and responsive to that, and also policymakers, do they have a greater duty nowadays to become technologically savvy?
Well, I certainly agree that everyone has to be taught to live in this fast-changing world, and of course social media and all that have changed the entire political discourse and how we interact. But as regards whether things are changing faster than before, of course there is the counter view. There's the book by, I think, is it Robert Alexander, who wrote a book on economic change, and he made the point that actually the changes that happened between 1870 and 1960, 1870 and 1950, which saw the railways, the car, refrigerator, television, and all that, made more difference to people's lives than anything that's happened since then. So it's not at all obvious that, although we have all these gizmos now, it's not at all obvious that in terms of affecting our lives, they are more important than the things which were already in place by 1950.
Thank you very much, Lord Rees. You started your talk with a quote from Lord Birkenhead, and we all laughed because Lord Birkenhead had, we might say, naively assumed that gender roles would carry on exactly as they had been in his day.
Yes.
And we all laughed. We thought, silly old chap, how did he not notice something so fundamentally different in society? So I wondered, what change might there be in 100 years where people listening to your predecessors talk will look back on us and say, silly old people, why have they not noticed this huge thing that's actually going to change perhaps quite significantly some of the things that you've mentioned. And I do wonder something like humans who live in language, the notion of deconstruction, the notion that reality is not dominated by aggressive males all going out after research-funded competitive results. There might be something like cooperation, heaven forbid. There might be people who actually want peace.
Yes.
Could such a thing be? What would your prediction of things we might miss be?
Well, I mean, taking the example, but not trying to be like Lord Birkenhead, I'm going to be cautious. But let me just say two things which I think will become routine. One is vegetarianism and the other is euthanasia. I would think that those two things will become standard and accepted 30 years from now, and we will regard euthanasia as a normal thing, and we will regard eating meat as really cruel and primitive. Okay.
Let me come on to onto my vote of thanks for Martin. I just want to be very brief. You've given us immense insights, an extraordinarily incisive mind and breadth of compass. And really quite remarkable. I think you have made, I come back to a comment I made at the beginning. The House of Lords is a sort of death. No sort of death here. Yeah. And in fact, I think you have made the case for a second chamber as strongly as I've ever heard it made. An independent second chamber as strongly as I've ever heard it made. And now, this has been, there's been a lot about death. For example, we hark back to Demis Hassabis, who gave his talk. Did anyone hear him on Desert Island Discs? Remarkable. And one of his choices was, who wants to live forever? Yeah, people are also fans like me of Freddie Mercury and Queen. Yeah, so who wants to live forever? Anyway, I think the answer was no on that, so he's probably not so much in sympathy with Kurzweil. Anyway, despite all of that, this has been a lecture of immense optimism and insights. And you have expanded the empires in our mind, and thank you very much indeed for that, Martin. Thank you.